Hello everyone, this is D. Sharanya from CSM department. Today I am going to explain about traversal in a singly linked list. First we discuss content of this topic. First, definition of traversal used to visit each node, important basic operation and where it is used. It is used in many applications. Introduction of this topic. Linked list is dynamic structure, nodes connected using pointers. Memory is not continuous, it is efficient in insertion or deletion. Singly linked list. A singly linked list is each node has data and the link points to next node. Last node points to null and it is simple and widely used. Structure of node contains one is data part and another one is the pointer. Data part stores the values and pointer stores the address. It is represented as data and next and it forms the chain structure. What is traversal? Traversal is a process of visiting nodes. Starts from head node, continuous till null. Access data sequentially. It can see the every node. Algorithm steps for traversal in a singly linked list. Initialize temp is equals to head. Check temp is not equals to null. And again display the data and move temp to next. Pseudocode temp is equals to a head and again enter into the while loop and temp not equals to null. Print temp into data and again temp is equals to temp into next. Program for traversal in a singly linked list. First hash include stdio.h, hash include stdlib.h. Define structure of node. Struct node int data struct node into next and flavor brackets close. Function to traversal and print the linked list. Void traversal struct node into head flavor brackets open. Struct node into temp is equals to head while temp not equals to null. Then printf %d greater than or equals to temp greater than or equals to data. Temp is equals to temp greater than or equals to next flavor bracket close. Printf null n. Int main creating a nodes manually. Struct node into head is equals to struct node into manloc size of struct node. Struct node into second. Struct node malloc size of struct node. Struct node third is equals to struct node into malloc size of struct node. Assign data and link nodes. Head greater than or equals to data is equals to 10. Head greater than or equals to next is equals to second. Second greater than or equals to data is equals to 20. Second greater than or equals to next is equals to third. Third greater than or equals to data is equals to 30. Third greater than or equals to next is equals to null. Traverse the list. Printf linked list is traversal. Traverse head return 0 and flavor bracket close. This is the program of traversal in a singly linked list. Example and output of the program is the list has 4 nodes. 10 is greater than or equals to 20, 20 is greater than or equals to 30, 30 is greater than or equals to 40. First start at the first node and visit each node from the last at the last. The output of that program is 10, 20, 30, 40. Time complexity of traversal in a singly linked list. Traversal takes big of n. N is number of nodes. It is a linear time complexity and it is efficient for small lists. Applications of traversal in a singly linked list. Searching an element, displaying the list and updating the data of the pointer, And continuing the notes. These are the applications of traversal in a singly linked list. Advantages of traversal in a singly linked list. There are four advantages of traversal in a single linked list. First, it's simple implementation. Second, no extra memory needed. It is a sequential axis, flexible structure. Finally, the conclusion of this traversal of a single linked list is traversal is essential. It is used in many operations and it is easy to understand at every time. It is important for exams. And finally, thank you.